Assalamualaikum and hi. We are from class AS1205E would like to present about the determination of food dyes in vitamins using Hplc. Now, I'll be talking about high performance liquid chromatography or known as Hplc and how it is used to separate food dyes. Hplc is an advanced analytical technique used in chemistry and biochemistry to separate, identify, and quantify components in a mixture. Hplc has three main functions. First, separation. It separates the components in a mixture like food dyes. Second, identification. It identifies each component based on their unique properties. And the third one is qualification. It quantifies how much of each component is present. In the European Union, the use of dyes in food and pharmaceuticals is carefully regulated. For example, dyes are allowed in food products and set strict purity standards. These dyes are added to make vitamins look better. Using techniques like Hplc, we can accurately identify and measure these dyes to ensure they meet quality and safety standards.
Hi, I'm Iman Azhar, so I'm gonna continue to the methodology part. Our method has three components, which is chemical and solution, sample preparation, and the last one is instrumentation and Hplc analysis. For chemical and solution, in this experiment, we use two main solvents for the analysis, methanol and acetonitrile. These are both high-grade solvents suitable for Hplc. The standard dye we use include quinoline yellow, ponchau, trazodone, sunset yellow, and carmine. For preparing the solution, we also use sodium acetate trihydrate to make a buffer solution. All solutions were prepared using ultra pure water to ensure the highest quality of the sample preparation. We test various vitamin samples including vitamin E, C, A, D, and vitamin D, which came in the form of tablet or capsule. First, we accurately weigh the capsule or tablet and then dissolve them in water by heating. To help extract the colorants from the vitamin, the sample solution were placed in an ultrasonic bath for 50 minutes. After the extraction, the solution was centrifuged at the high speed to separate any solid particle. Then, the liquid was filtered through a fine filter to make it clear. Finally, we collect the filtered liquid in a 10 ml flask. 1 ml of the liquid was transferred to an Hplc vial, and 20 microliter was injected to the Hplc system. For the analysis, use an Hplc system to test the vitamin sample. The system includes a detector that measures signal in the range of 190 to the 800. Use a C18 column for separating the sample and inject 20 microliter of each sample into the system. The column temperature was set up to the 40 degrees Celsius. The mobile phase and flow rate were adjusted based on the color of the capsule. For red capsule, the flow rate was 1.2 mm per minute and the mobile phase ratio was 20 to 18. For yellow capsule, the flow rate was 1.0 mm per minute and the mobile phase ratio was 10 to 90. Each sample was tested 3 times to ensure the results were accurate.
Next, I'm Nufara Ainajwa will talk about result and discussion. So, this is the result, which is a show about chromatograms of coloring standard. Okay, next, in the discussion, the analysis of food coloring dyes was carried out using a reverse phase high performance liquid chromatography, or known as RP-Hplc. This method equipped with a dye area detector, or known as DAD. This method is highly effective for separating and quantifying multiple dyes in a single run. The chromatograms in figure 3 show that a distinct pitch for each dye, allowing for easy identification and comparison. The dyes analyzed include poncho for art, tartrazine, quinoline yellow, carmine, and sunset yellow. Each peak corresponding to one of these dyes demonstrate the precision and reliability of the Hplc technique in analyzing complex mixture of colorants.
So hi, I'm Nusrat Atira Izam binti Muhammad Izani. Let's jump to the conclusion, which is this study analyzed the presence of quinoline yellow, sunset yellow, poncho for art, tartrazine, and carmine in vitamin preparation using Hplc. It is also revealing that these dyes are added in small amounts and remain below the maximum permitted level set by regulatory authorities. So, the findings indicate that exceeding the acceptable daily intake (ADI) would require consuming hundreds of tablets and making the risk minimal on the normal users. However, while synthetic dyes in food receive significant regulatory attention, their use in pharmaceutical often goes unnoticed, as manufacturers rarely disclose the origin or exact amount of dye in their products. To address this gap, it is recommended that companies enhance label transparency by clearly identifying the type and quantity of dyes used, enabling the consumer to make informed decisions and fostering trust in pharmaceutical safety.